The dot product of A and B, if A is defined as A1, A2, and B is defined as B1, B2. To find the dot product, we multiply A1 and B1, and we add the multiplication of A2, B2. Two vectors with the dot product of 0 are called orthogonal. An example here, we are asked to find the dot product of U and V, then determine if U and V are orthogonal. U and V are 3, 6 and minus 4, 2 respectively. So what we do is 3 times minus 4 plus 6 times 2. We get equals 0. So these two vectors are orthogonal, as shown in the diagram on the right. We can use the dot product to find the magnitude of a vector. If we are given a vector A equals minus 5, 12, to find the magnitude of this, we can do A squared, which is A dot A. We can then use Pythagoras to do the square root of minus 5 squared plus 12 squared equals 13. We can also find the angle by using the formula cos theta equals A dot B divide the magnitude of A and the magnitude of B. An example, we are asked to find the angle between the vectors U and V. U equals 6, 2 and V equals minus 4, 3. If we plug in the numbers, work it through, we take minus 1 cos and we get the answer 124.7 degrees.
Now before we continue, please don't forget to like the video and subscribe to our channel. As a reminder, we offer private and group online math lessons on Zoom. The first session is always free. We cover all UAE National Curricula, American and British curriculums. We also have the best MSAT math test preparation course with a 50% discount for groups. So if you are interested in a free lesson, click the link in the description below, and send us a message now. Okay, with that said, let's get back to our lesson.
Okay, now vector projection. Vector W1 is called the vector projection of U onto V, denoted as the following. We can see here on the right what the projection would be, shown by the red line. An example of this would be, we could be asked to find the projection of U onto V. U equals 3, 2, and V equals 5 minus 5. Step 1, we can find the projection using the formula. We plug in the dot product and the magnitude, and we work it through to get 1/2 and minus 1/2. Step 2, we can find W2. Since U equals W1 plus W2 and W2 equals U minus W1, we can find W2 by working it through and getting the answer 5/2, 5/2. Here is a real-life example that we can use to find a force of a car going down a hill. Here is the question on the left-hand side of the screen. We can use the following steps to find the force of the car going down the hill. We can find a unit vector in the direction of the hill by doing the following and using the formula shown in the last lesson. V equals, the x component is magnitude of V cos theta, and the y component is magnitude of V sin theta. We work this through, we get the answer √3/2 and 1/2. To find W1, we can use the formula in the previous slide, and if we work it through, we get the answer of 0 minus 3000 multiplied by V, which equals minus 1500 V. We can also calculate something called work, which is the force in any direction moved on an object from point A to point B, as shown in figure 3.9. We can use the vector projection of F onto AB. Using this work formula on the left-hand side, we can work it through and we get the force times by the vector AB. Here is a real-world example of roadside assistance. We can use this method of the projection formula. The magnitude of the projection of F onto AB is F cos theta, which is 120 cos 45, and the magnitude of the directed distance is 10. If we work this through with the formula, we get 848.5 is the work done. Okay, here are 6 questions for you to try. I will give you time to pause the video now, try the questions, and if you are unsure about any of the questions, please go back during this video to help you answer these 6 questions. Please do try now, and the answers will be revealed on the next slide. Here are the answers to the 6 questions. Please check your answers, and I hope you got all questions correct. If not, then please do go back through the video to find out where your errors could be.